Hi guys, so we are back again. This is the third part of the three-part series for elements, compounds and mixtures for class 6 chemistry. The other two videos, the part 1 and part 2, has already been uploaded. The links to the videos are down there in the description. Please go through it. Okay, and here we start the third part. In the third part we go with mixtures. Okay, to understand mixtures, I hope you have understood compounds properly. Okay, why? Because mixtures and compounds are pretty much similar with few changes. Okay, quite a few changes. Okay, so let's go with the definition of mixture. A mixture is an impure substance which is formed when particles of two or more elements or compounds are physically mixed together in any proportion. Compound was a mixture of two or more elements. Mixture is made up of two or more elements or compounds. Okay, and compounds and elements, they were pure substances. Mixture is an impure substance. What's the difference between pure and impure substance? It's very simple. Okay, a pure substance, for example, water is a pure substance. Why? Because it has got fixed ratio. Okay, there are two parts of hydrogen and one part of oxygen in every molecule of water. Every molecule of water. No matter where you go, okay, you will never find a molecule of water which has got 5 atoms of hydrogen and 6 atoms of oxygen. Not possible. Right? Because the proportion and the ratio is fixed. 2:1. That's the ratio. 2 parts hydrogen, 1 part oxygen. But when it comes to impure substances, there is no fixed ratio. Okay, for example, coffee. Okay, I like my coffee without sugar. Without sugar, still a coffee. Somebody might like coffee with 3 tablespoons of sugar, very sweet. Right? Still a coffee. Coffee is a mixture. Next, we move on to the properties of mixture. Here are the properties of the mixture. Let's go through it. We have already discussed about this before, so we'll just revise through them. In a mixture, the components are mixed physically in any ratio or proportion. We have already talked about it. Okay, it does not have a fixed ratio or proportion. We've talked about that. Next, the individual components of a mixture retain their original properties. Remember, in compounds, that is in water, the property of the oxygen, that is gas, and the property of the hydrogen, that is gas, when they come together, it disappears. It turns into liquid, that is water. But in mixture, the properties of the substances, they stay same. Okay? Next, the components of a mixture can be separated by simple physical processes such as winnowing, sieving, filtration, evaporation, etc. Winnowing is basically a simple thing. Okay, like for example, you have peanuts. Okay, you rub the peanuts and you get that outer shell, right, of the peanuts. You can just blow it away using air to separate things. Okay. Or substances. When you use air to separate substances, it's called winnowing. Sieving is using a sieve. Okay, sieve is like a mesh net kind of a thing. You put stuff into it and then you shake it and then you separate finer substance and slightly crude substance. For example, we do it with wheat or flour at home. We put that and we shake and then we separate the crudest substance with the finer substance. Filtration is basically, we do it mostly for liquids, right? And you have seen a filter, water filter. Water filter is used for filtration. What it does, it separates the impure stuff from the pure water. Evaporation is when we use substances. When we have substances, we want to separate it. Okay, like for example, let's say we have got wet sand. Okay, we have got wet sand and we want to separate the moisture from the sand. What do? We heat it. The water gets evaporated and what is left is just sand. Next, we move on to formation of mixtures does not involve any energy exchange. Right? Remember in compounds, when a compound is made, right, when elements come together to form a compound, energy is either absorbed or released. We talked about that. But when it comes to mixture, you don't need any energy. Okay, next, very important, very important, heterogeneous mixtures and homogeneous mixtures. Very important and very simple and very easy to understand. So, let's look at homogeneous mixture and heterogeneous mixture. Okay, it is a mixture in which components are distributed uniformly, equal portions are added, okay, throughout the mixture. Like for example, juice. Okay, there is, no matter where you drink the juice from, okay, if you just drink it from the surface or down at the bottom, still feel or taste the flavor of the juice. And other examples are sugar solution or salt solution and tea. Okay, heterogeneous means when it is not uniform. Okay, it is a mixture in which the components are not distributed uniformly throughout the mixture. Okay, so mixture of salt and pepper, mixture of chalk and water, mixture of oil and water. Mixture of oil and water, you might be able to understand it. Why? Because you have seen it. You take a glass of water, you put like 2 tablespoons of oil, mix it. You can never mix it. You can never mix oil and water together. Oil will always stay up, okay, and the water will be down there. They will never mix together. They're enemies. And finally, we come to the end, okay, and these are the few things that I want you to go through. On page number 20, there is a periodic table. Please go through it and memorize the first 10 elements, just the first 10. On page number 24, there is a diagram of an atom. Please draw it in your notebook. On page number 26, there is a table with the differences between atoms and molecules. Go through it. It is very important. Page number 26 and 28, you will find chemical formulae of elements and compounds. Please go through it. Again, they are very important. Lastly, on page number 29, there is a table with the differences between compounds and mixtures. Please go through it. These tables, please copy it in your notebooks. Thank you guys. Thank you for watching this video.